Let us now try to talk about something called as L value and R value. These do not refer to as right value or left value. They just refer to as L value and R value. So let's say I have declared a variable called as temp. Its data type is int. So I say int temp is assigned the value 100, something like this. Okay, you can visualize it like this. I declare it like this. I say int temp is assigned the value 250. All right, so I do a declaration like this: int temp is assigned the value 250. Then what happens is its picture in memory is something like this. For me and you, the name temp identifies the address or the memory location 1000. The data type is integer and the value it holds is 250. So by this, what we really understand is I have a memory location whose address is 1000. User has given the name temp so that I am able to identify that memory location. Don't think temp will always get the address 1000. The compiler will assign any memory which is available at that particular point of time. And I give it the initial value 250. So name is temp, data type is int, resides at address 1000 and its value is 250. So let's understand what do we mean by L value first. This address refers to the L value. So in this case, L value is 1000. L value simply means a memory location or an address where the data is going to be stored or the data value is going to be stored. Now, what is R value? R value refers to this number 250, which is the value that is going to be assigned to this memory location 1000. So on the left side of an assignment statement, this is an example of an assignment statement. The left side of an assignment statement must always be an memory location. You can't assign, you can't do something like this. You can't say 2 into 3 is assigned A. This is meaningless because this is a memory location. This fellow is not a memory location. This is a calculation. This is a calculation being done in the program. It is not any memory location. So you can't take the value of A and give it to 2 into 3. So R value refers to the value that is going to be assigned to temp. In this case, it is 250. All right. So R value of temp is going to be equal to 250. Now let's understand a few more things. Now, so there are certain rules which need to be followed regarding R value and L value. All right. A value can be assigned to an L value only in an expression. For example, if there is a memory location, you can only give it a value. I can give a value to A like this. This is an example of an expression. The result of this gets stored on the left side in A, where A represents some memory location 1000, 2000, whatever it is. Either you can assign a value like this, or you can give J the value of A like this using the assignment operator like this or like this. There is no other way to assign or give value to a memory location. Just remember, this is an assignment is an operator. It is not equal to. Now, the expression to the left of the assignment operator, on the left of this fellow, should always be a memory location, also referred to as L value. Because why it needs to be a memory location? Because whatever calculation you're doing on the right side needs to be stored somewhere. If it is not a memory location, where is it going to be stored? Okay. Constants can appear on the right side of the assignment operator. They are not L values. Constant identifiers. For example, I can say A is assigned pi. Pi represents 3.142. But you cannot say in a program pi is equal to A because pi is a constant memory location. So constants, names of constants can appear on the right side, but as they are not L values. For example, if I declare a constant like this, let's say I try to do something like this. Okay, I have a constant pi. Okay, let's say constant float pi. Okay, is 3.142. I cannot say A is assigned the value. I can do A is assigned the value pi, assuming A is a real number. but I cannot say pi is assigned the value of a, because pi represents a fixed or a constant area which cannot be modified. All right. So this is some part of it. Now let's take a look at a little more about declaration of variables and how do we initialize them at run time. Now, first take a look at this code segment, then we'll go to the theoretical part. That's always easier to understand. In the code segment below, I have declared a variable int a and b. Using this cn, I'm reading values into a and b. Let's say I'm reading the values 10 and 20. A is 10, b is 20. Now, what I have done is I have, after the declarations, after reading, I have declared one more variable called as temp of the type integer, given it the value of a. I'm using this code to exchange the value of a and b. So what it means is, this is one way to declare a variable. This is another way to declare a variable just before it is going to be used. So you can declare a variable anywhere, at even at runtime. This is created just when the program is running, and a variable can be given any value anywhere in the program before it is used. But important to see that when it is created, be sure you assign it some value, otherwise it will take some random garbage value. Now let's understand what is this const keyword. All right. Now, if you look at this declaration, I'm saying int a value 100. Now I can make a to 200, 300, anything. But if I say constant int b is equal to 200, a can be changed anytime in the program, but b cannot ever be changed. It is a constant or a fixed memory location whose value does not change during the execution of a program. So const is an example of a keyword, and it tells you that you cannot modify that particular memory location. So I hope this clarifies something about lvalue, rvalue, declaration of variables, as well as how do you go about using the constant keyword to create memory locations which cannot be modified.